Hey, how's everybody doing? I've been playing with the bots. I think like everybody, I've been really swept up by the whole ChatGPT craze, but I've been not just caught up in the hype of it, but I've been actually it's really inspired me to try to get deeper into some of the machine learning stuff in the background, which is not trivial. It's like one of the things it's I think most of us are aware of. Like people have been doing the machine learning. That's why we have ChatGPT, because it's been a popular industry for a long time. So while it's inspiring a lot of people to start to look a little bit deeper, it's also something, there's thousands and thousands and thousands of professionals who've been deep on this for a long time. So there's the science around it is thick, and training bots well is a really deep subject matter that you can spend years and years. But an interesting things about ChatGPT is it really changes the game in getting into just about anything. And ChatGPT is also really good at helping provide guidance at how to train bots. But the part that interests me more is not just that it can help you learn and help you actually do bot training, or data set preparation, fine tuning, et cetera, right? It's that there's the key thing about training machine learning algorithms is you need data that's already verified in order to start to train it, right? Like, how does it know, thinking about like answering questions and answer type of things like you often do with a chatbot, how does it know what a good answer looks like? It knows like a good answer, it looks like, because it's verified, usually by humans, that this looks like a good answer, that looks like a bad answer. And so, historically, a lot of machine learning tasks where, you need huge amounts of human validated content that is accurate, that can teach the AI what represents the right answers from code completion, et cetera, right? You need human data for that. And that's the rough part, where a lot of us are on a lot of things. We've got data, we've got all types of unstructured data, static documents, and all types of data records and things like that. We can find data, but getting data that's the right type of data is really hard. And I think that the game-changing thing there is ChatGPT itself can give human-like analysis and human-like response to a lot of data analysis issues. And so let's say you have large amounts of data that you need to have some sort of validation or some sort of human touch on, if you will, right? In many of those cases, you can have ChatGPT provide that a simulated human element, and in some cases may outperform the response of a lot of humans on certain tasks. So I've been, with that in mind, I've been really wanting to train these bots, thinking this really accelerates. One, you build on top of what ChatGPT already has, right, which is really powerful. We played with it. We also know if you go into the regular web interface and you start to have a conversation in a tab with it and starts to know something about the conversation you've had. But if you do that for a while, you realize in a tabbed conversation, it starts to get lost. Right. And it's not actually doing training there. And I can create the impression that, I can build on ChatGPT, but will it actually, and I think the key is you have to do an actual build a proper training data set and do the actual fine tuning of the bots. And I think the other key thing is when you're building on top of ChatGPT, the amount of actual records that you need to have an impact, at least my belief is it's going to be a lot less. You may have things in the order of hundreds to maybe a few thousands of records that you want to use to tune for a particular thing, actually do quite an effective job, because you've already had the millions, billions, and years of effort that's gone into ChatGPT itself to layer your model on top of. So I don't have that all done yet, but I want to catalog my progress into this model, and I've got some cool things to show that highlight that point. And but first, let's talk a little about the context of what I'm analyzing. 'Cause I wanted to make like a Tanzu bot. That was what I thought I was gonna let's play around and make a Tanzu bot. But you know, I've was assigned to a project and that has got me really interested in a couple new things, right? So one thing, so you may have heard of VMware Area Graph, and Area Hub, and it's just really, really cool stuff. Right? They're able to model, you know, entire cloud infrastructures with just thousands upon thousands of assets in the cloud, and it's just a really beautiful UI they're able to layer on top of it, which signifies, you know, this efficacy of the data modeling they're doing underneath. And you know, so that if you start to get further into that, it leads into this, you know, item project, which is a data flow oriented programming language, right? And you know, I actually first saw this months ago, and it's one of the interesting things about human nature is like you tend to be more open to new big ideas when they come from a place that you're expecting them to. And I think for me, I'm so caught up in the Kubernetes world, you know, it's like, yeah, if anything's worth it, because there's so much going on. Like, how do we know, even if we're, you know, pretty sharp ourselves with all the projects that are out there, and they're just growing faster and faster, thousands, millions of projects that are happening all the time, constant influx of new technologies. And even if you have the skill to like look at something and really make a determination about how good some new technology is, I mean, to verify some of these things, you've got to spend a lot of time getting into depth to really validate whether something is you know, something you should spend more time on or not. And so, you know, I first started looking in this item project a few months ago, and you know, I was like, wow, this says it can do a lot of really, really cool things. Um, you know, just a really big vision. Do I trust it? I don't know where. I didn't know anybody behind it. All of the technologists that I work with, or we've all been focused, you know, almost very, very in the silo of Kubernetes, where this is, you know, a little bit outside of Kubernetes. And any long story short, I wrote it off for a while, thinking that, you know, it seemed like there was a lot of just really big grandiose claims, and the technology, the beta at the time was is pretty new. You know, this was a long time before Aria Hub came out and all that. And so, yeah, I just thought we'll see what happens, but I didn't. It seemed like it was a little bit overhyped. But I've had a project that's caught me to get more into it, and now I'm really starting to look at it, and been going deeper and deeper, and watching lots of videos and doing a lot of it's a initial investigation and more exploratory analysis. And I think it's really, you know, on to something here. But, you know, then the challenge when you get into items is it can do really cool stuff out of the box, right? And I do have some immediate thoughts when it comes to the use cases it's already prepared for. But the part that excites me most about item is like the language itself, and really gets involved into like being able to, you know, develop plugins for other things that it's not adapted to yet. That's the area that's really kind of caught my key interest. And you get into item because it's a new project. It's got some great documentation. It's open source. You have the source code online, all that. But it's you know, it's still a new project, and it's still not, you know, not huge outside of the VMware ecosystem, and so the amount of documentation is still, you know. And if I was like a super guru, you know, a lot of the stuff is in Python. If I was a super guru, I might be able to just dig in and run full speed ahead with just what's available right now. But I thought, you know, it would be great if I really want to get going on this item project. It's pretty, you know, a lot of depth to this. It'd be great opportunity here. What if I made a bot for it? As I've also been, you know, theorizing, like you can really start from the very, very early stages of a software project to start to get insights right from the beginning, because, you know, ChatGPT, in addition to, you know, well, it's not, you know, doing a lot of preparing training data sets doesn't necessarily involve ChatGPT, right? It's just preparing. You can use a lot of utilities to do a lot of the data set preparation for you. And yeah, and so you do a bunch of data set preparation, and you know, for these projects, And then we can bring ChatGPT though to really make the difference, because it can look at that code and it can start to label it and categorize it and provide annotations and provide questions and answers that may arise and describe the functionality, just from starting with things as simple as source code, and you start to get a little documentation, start to feed in, your Slack channel data and things, that your support ticket data, engineering data. And little by little, I think if software projects start using that from the beginning, you start to scale out to additional technical people, from onboarding additional developers to eventually bringing in QA and testing, to bring it out to like technical marketing and sales as the products grow and mature, and product management, et cetera. You can have bots that are trained in whatever your marketing copy is for the marketing side of projects, and so on. So that great opportunity here this would really can we start with limited data and actually make something really useful, and at the same time, can that help me to really get accelerated in the item project? And item project is really based on this really, well, it's built on this really thing that I find just a really interesting concept. Spent a lot of time last week. Let's go to this. Going through, not issues, sorry, we get to the homepage here, going through this thing called plugin oriented programming. And I mean, I was talking about plugin in the word, it just, to me, it didn't sound as big or as serious just from the name of it as I thought, initially. And like getting into this is really a serious programming paradigm. I mean, they're really developing a lot of really cool modern software patterns in using this paradigm called POP, which is really about treating everything as a plugin, right? Because we're incorporating all types of libraries and code and so on, and so really having a framework and a methodology around it to be able to support it, because it's an easy concept to kind of understand, right? Like we have so many, we're doing microservices, right? We've got teams that could potentially be working on different code projects. Open source has grown so much, generally, more so than any time in the past. Like you can think about an app, you start thinking the amount of libraries, the amount of open source code that may be available to help support my project. It's more than ever, right? And so, and there, I think there's a lot of times too, there's a lot of development teams that find themselves in situations. It's like, ooh, well, we want to work on new project A, right? And but what if that particular project, there's tons and tons of really valuable code and libraries that exist in the language that you weren't thinking about. And microservices architecture, you can incorporate it, right? But in any case, POP is still largely built around Python right now. Conceptually, it's not something that's stuck to just Python, but it is an interesting way thinking. We're going to microservices. We want to keep things really small and tidy, and can that actually change how we think about it? Like if it's an alternative to say something like object-oriented programming, where we really start to think about things differently. But I'm just going to get to the point here instead of dragging on more about that. You can read more about POP if you're interested. I think the main point of my focus here isn't so much about POP or item. It's really about, here's a project. It's a newer, smaller open source project. There's not tons of documentation. You can't just go Google search and find, lots of people out talking about this stuff yet, because it's still pretty new. So I thought this is a really great way to really test and see how well the bots can do from having the limited information again. So what I'm doing right now is starting with the source code for POP, and I'm going to use this to generate training data, and go into the documentation for POP, use that to generate training data. And we'll do some checks at that point. I want to bring this into the bot, and we'll do some analysis and see how effective the bot are at solving various challenges that we have in our test set as we go through different things. But it started with POP, start with the source code, add the documentation, and then we have source code for other projects that were built on POP. And then we've got item source code, item documentation, a few other, I think I've got some source code from public source code, open source, right? For some other item plugins and things like that. And so here we are, getting to the point. Let's look at what I've been up to here. So we'll get into the code. Okay, so starting off, I've been gathering a couple different methodologies, right? So from the source code, starting with a couple different methods, I'm going for gathering embeddings, right? So, but there's a big process. You start with source code, and you need to to go through a couple transformations of the data before you can get to this thing called embeddings, right? Like first you have to clean your data set and prepare your data set, and then you do something called tokenization, which prepares a bunch of it's like an array of numbers. We'll say numbers, right? That signify both the kind of the mathematical significance of a word as it relates to other words. And so when you have a tokens, you have a kind of like, to describe words, you end up with a few primary words. Like you see individual words are tokenized, but it also leads into like a string of additional numbers that can be used to calculate relationships with other words and probabilities of what other words might be used in the context of what you're working on. And after you get through tokenization, the next step is moving to embeddings, which take this string of numbers that you get and use vector math to create a vector based on that string, which is just kind of like that additional step in processing the mathematical relationship and the probabilities of what words are related to the words that you might use, and so on. So, that math stuff with this, I mean, it gets really deep. I think there's very few people who really understand that in a super deep way, but net, you can understand the ballpark. I think of it a lot like, public key cryptography, right? A lot of us can, we'll go and get our SSL certs. Some of us are pretty good at, rotating certs and all that and how cryptography works. But at the end of the day, I mean, like, how well does the most of us really understand like how mathematically some of us do, right? And I don't mean to, at super deep levels, but a lot of the stuff, my point in bringing cryptography is you can be very effective at using it without, really being able to like calculate every deep aspect of the deepest areas of the maths. So I'm starting with the source code. I'm working on two areas, creating embeddings from the entire base of source code, and then also using snippets. Snippets is an effective, they're both good because snippets are a very common way to probably the more common way, because it is you've got to go and gather like this human intelligence and other forms of information about the data that you're trying to use to train the model. It's a lot easier just to start with snippets. You have a smaller, more succinct base of items that you can kind of go through one by one, rather than like source code. And you can still get a lot of the insights. Now, I think it's also good to like use the source code itself. There's a lot of additional context that when you actually go to use ChatGPT to have it provide labels, annotations, and questions and other descriptions of your actual data. If you feed it your full source code with your hopefully you've got some nice comments in your source code and all that, it's able to use all that contextual information to make even richer descriptions of your data set. And so starting off with snippets, I've got my stuff organized into the code I'm using and the results that I'm getting. And so first thing, I want to go through and get the snippets. I actually started ask ChatGPT for this. There's tons and tons of work, right? I mean, thousands, hundreds of thousands, millions, I don't know how many machine learning scientists that there are out there, and engineers and people who work on it, hobbyists and so on. But this information is out there in the wild, and you could spend a lot of time getting into those communities, get to know it. I asked ChatGPT to shortcut me and help me arrive at this script, pretty easy, right? And so this actually does a really nice job of going through an entire directory or repository of source code and abstracting code from it pulls out, it cleans out a lot of different things. It cleans out comments and stuff, which may or may not be desirable, but it actually is for to clean it out like that. It is desirable for different things. So what we're going to do is we're going to make some tokenizations and embeddings that is purely based on code alone. And then separately, we're going to have another one that has a combination of the code tied to rich contextual data. And so starting with this initial layer of abstraction and to get just the snippets and then to clean them, remove all the white spaces and other things like that that the computer, the computer doesn't necessarily need, is where we'll start. So this code here, we'll go ahead and go through that directory and create the snippets. And let's just look at the results of what our snippets look like at first when we first gather them. And so we can see here, it's like function, 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 and we have this kind of grabs all the logic out of our code files, which is mostly logic to begin with, right? But it cuts out other things. And this feeds it all in one big file. It's a few thousand lines of definitions, right? And so when you're proceeding down the path to tokenize based on just the raw code itself, then you want to go ahead and like clean the snippets. So I've got some code here that will clean the snippets out. And just to, rather than going through the code line by line, I got a lot of cover here. I'm just let's what clean code snippets look like. Right, so it distills it even more into, an abstract state. And there's good and bad to this, right? Because this helps with things like, these are all kind of the main keywords and some of the common patterns that exist. But as you can see, these aren't all the common patterns. When we think about, this is going to give some insight into your code. But we also think when we're doing code generation, right? We want to see complete examples of code and being able to go from that as well. And the great thing is we don't just have to choose one or the other. We can use these, we can distill all these down and then combine them together to a common data set. So it'll have the benefits of all the different methods, right? And once we clean our snippets up, we're gonna go ahead and tokenize, right? So we've got our tokenizing scripts. Again, ChatGPT is super helpful in getting the code together for this. In some cases, it'll just like, hey, here's complete working code. And most of the time, I've got to come through and either do things like maybe it's initial suggestions I didn't like, so we'll go back and forth on parts of it, and it'll give me a piece of code that's mostly done, and I'll go, after a little back and forth, and I'll go through and just give it a little massaging to get it to work and the way I want. And so in this time, we're using a library called sentence piece to go ahead and tokenize the data. And we can see here, once we have our tokenized code snippets, this is what the tokenized file looks like. So, not especially meaningful to your eye, right? And cool. And that's, then we could start to move forward with additional conditioning before this is quite ready for our data set. And that's fairly straightforward. I'm going to make some with the code alone. But I don't just the code alone itself, that's going to be useful for some aspects of my task. But whether it's asking questions or explaining or writing documentation or generating code itself, is having that additional context associated with the code is a very, very useful thing. And so and that's where ChatGPT is really going to make, because if I just have the raw code here like itself, it's not enough to make much of a dent, right? Really need to be able to associate this with annotations and data labels and things that provide rich descriptions of what the code is. And that's the fun part, is we're going to get into the ChatGPT API here in a minute. So let's see, where was I? So then we got our some one hot encoded tokens. That's what we did next with the non-annotated tokens, but now we'll get into the annotated tokens. So I'm off in the test directory now, because we're still testing this part. And so we've got some interesting, so we go back. So we've got our snippets before we've done any tokenization, because for this part where we're going to add some rich context to our data, we're going to, again, tokenize this file separately. So I'm going to take these snippets that we generated, and again, all that I did to get this is I cloned the pop repository, And then I was able to execute my extract snippets Python script and to go through, and it created this nice file of code snippets, right? And this is cool. And what I wanted to hear is we want to add lines that we call annotations that'll have a nice description. And depending on what you want to do, are we trying to do code completion? Are we trying to do questions and answers? Are we trying to augment documentation writing? What you want from your ideal annotation is you can have them optimized in a slightly different way. And again, really great thing with ChatGPT. You can ask ChatGPT if you want to ask it for annotation, you can try to ask it for the type of annotation. And I don't think there's any perfect information yet, right? I've noticed ChatGPT gives some good starter suggestions, but a lot of times its suggestions, may not, are not right. Even when they work, they're not necessarily the optimal suggestions. I've worked with, and there's actually some scenarios I've been in where it's suggested something, and I said, that methodology doesn't seem optimal, and it didn't quite realize that. And I go back and ask it about it, and say, oh yeah, it essentially will realize that it hadn't taken a consideration into perspective, and then evolve its own thinking based on suggesting doing it a different way or something like that. So it's really interesting relationship with the bots as we go through. So what I'm going to do with this data here now is that I need to be able to add some delimiters in here, so I can programmatically go through these and treat these as one function at a time. Because when we annotate the data, we want to annotate each individual snippet. And so, what is this function about? What is that function about? What is this function about, etc. as we go through. And so we'll just, that's the update delimiter. So I created this little Python script here. Well, there was another one I created to create delineation originally. And I don't know what I did with it, but then I updated this to essentially go through and add a delimiter in between each of the snippets. So we went ahead and did that, and then this cleans up the data, and the result ends up code snippets ready for split. Okay. So now here we have each of those files. And a couple of things I did. So I added a delimiter, but I did a little more than add a delimiter. I also added this triple quote, which helps ChatGPT. One, it helps it to segment. It helps it to start and stop very, very clearly. I experimented a little just using the delimiter at first, and there were times in some of these that ChatGPT would get confused by the prompt and not return the information I want, or return too much information, or make up information in addition to the information I asked. And the reason why is because it needs to know very clearly where to start, where to stop, and you can use grammar to give it some contextual clues. And also this triple double quote sequence is common in Python. And yes, it's kind of like a hint. You can put other types of code in between these, and ChatGPT will just figure out, hey, you're just using a delimiter. But it kind of a little bit better if the context clues, are commonly used together, even more so, perhaps, right? And so yeah, I was getting some responses where we'd come back with two different answers because it was getting confused about various things when I put this into my split and feed in the API, and so wrapping each of these functions made it just really crisp. So this was coming back very consistently. And so we've got each of these wrapped in the triple quote block. And I think, especially if these are Python functions, that's also helpful. And then delimiter in between. And it really makes it easy for me to go through a lot of additional data processing on these, because we're going to use this data in a lot of different ways. And I haven't even, we're going to put this over time. If you follow along with me, we'll get this into fully automated pipelines. But I'm going to do a lot of the initial experimentation on the models I'm working on with a lot of hand touch while I get them refined, and then get the code to where we're doing some automation, and then we'll build it into a fully automated data processing pipeline. And so after we go through, so I've got my code snippets ready for split. And really, this is where we're going to start to look at some experiments. But before we actually make some API calls. I want to show where I'm going with this. So there's, I don't know, 5,000-6,000 lines, and you could run this as one job, but I don't want to run this as one job. Like, I've got to do some calculations to see the costs on these are pretty low. Like, I imagine for this whole thing is probably going to cost, $10 or something like that worth of processing to go through and get annotations placed on all these data sets. Another thing too is like, it's good, but yeah, rather than trying to process this all at once, it's really good to break it into chunks so you can measure it as you go. But in addition to that, like, you could also do optimizations as you go. You've got even if you ask ChatGPT, hey, what is the best way to ask ChatGPT to give me information, right? I'm finding like little tweaks can make you huge differences. Little adjustments to the prompt that you give ChatGPT, like, hey, give me an annotation for this code snippet. How you ask that question, it can make a pretty big difference. And so I've worked with ChatGPT to get its advice on how I want it to ask me for the most idealistic and rich and robust annotations that I can. But I think as I run the batches of this, I'm going to go back through, see how the results are, and we'll need to do a little bit of statistical modeling over time too, to figure out, hey, if I run my data using the question worded like this, what are my responses, and start to compare those. And what if I worded the question a little bit differently when we compare the results of those? And just make those adjustments. There's so many parameters for tuning in here. We're going to require a lot of automation and time and testing to see what actually ends up working best. But I think before we worry about all that tweaking, we'll be able to get to a spot where we've got some pretty good results just on our initial hypotheses here. So yeah, so I have taken this several thousand lines, and I just got another little scripts. Where's this? It's in the code file. Where's the code? Snippet file splitter. So I have I'm using these delimiters, right, to delimit the data. And so I just wrote this to split on having 50 delimiters in a single document. And so that way we'll have, I don't know, 50, 51, whatever snippets per file, and we'll pass those through the OpenAI APIs in one batch at a time. And so ran that file, and it took my list of snippets, right, and we only have generated out to, so I've probably somewhere between 657 and 700 snippets. That's good. It's a good size. It's for in the past, that would have been pretty tiny number. But being able to use this cumulatively on top of what ChatGPT already has, that's great. And and this is just snippet annotations. We also have, the other processing from the snippets. We're going to do processing from the full source code. We're going to do some processing from the source code snippets that are based on the larger context that's available in the source code to get some different angles. We're going to look at documentation, and we can do other things too, like generating sets of question and answers from source code, generating sets of question and answers from documentation. A lot of ways that we can get some really, really powerful training data that normally requires just lots and lots of money and time and human input to get thousands and thousands of records with human input. We're gonna use ChatGPT instead. So let's look at talking to ChatGPT API here. So I haven't actually run all these batches yet. Where I'm at right now is I'm ready to run the batches. I've ran a bunch of tests against the API. You can see some of these API request successful things here in my thing. So I spent a while preparing how I wanted to gather this data, right? Is what we really want to keep the data stored in a way that we can do a lot of additional processing on the data. We also want to keep metadata back about it, and so hey, what format am I going to put this in to make sure that when I feed this to a tokenizer, that the tokenizer will be able to optimally make tokens for it. But I also want to make sure that I can process the data afterwards. So it's very common to use JSON. It's very common to use XML. But I was talking to ChatGPT, and it was recommending some like plain text formats where you just leave like a new line space. It recommended initially a format was just like code on one line. On the very next line, with no identification or marking, you have the description. And that's not bad for the tokenizer, because the tokenizer is really going to take the code and the word that's in your description and treat it as an object, kind of to create these, identifying these mathematical similarities. And so we're associating them. But there's so much room for error when you don't have any rich formatting, especially if you want to be able to feed this cleanly into multiple analysis tools. I kind of came up with, not came up with, I just decided to use a quasi XML, HTML style tags, but without conforming. And one of the reasons why I did that is because ChatGPT itself kind of recommended against JSON, and it kind of recommended against XML in favor of something simpler. And no wrong, it had JSON and HTML formats very highly rated in terms of its recommendations, but it indicated that they would be, not as good as maybe a raw text-based format, which had other issues. And so I kind of settled at, I just kind of created some HTML tags around it that made sense to me. And then I asked ChatGPT what it thought about my schema, and it said it really liked it. So I thought it would do very well. Thinking that it's doesn't have to conform to XML, it doesn't have to conform to HTML, but it has some of the benefits of that type of labeling. So each snippet, let's say, is I have in here is formatted as an A block. So let me take the second snippet, and we'll look at the data model here that you're going to gather this in. So the first thing that I have here, I open a tag I call A block. I did the A dash only because, since we're going to be processing this from analysis tools, we're processing code, and we might have common named HTML tags inside of the data that we're reviewing. And I didn't want to have any confusion, because even HTML, right, or XML, you're going to use a lot of custom tags, custom modules. And so I wanted to pick something that was a little bit unusual to make sure that nobody had created that. And it's one of those things, someone might have had the same thoughts. It's always good to be flexible with this. I don't have to use this. If you look at the data set, you start to whatever labels that you choose to use, go through your code base, or go through your or whatever it is that you're analyzing, and search for the sequences of the labels and tags that you're using, to make sure, and delimiters, right, to make sure that those aren't common in your code base. Like, one of the things is, I mentioned that ChatGPT works well with using triple double quotes as delimiters, and it does. But you find, if you're like asking ChatGPT a lot of questions about Python, the body of your content that you're asking about may have these delimiters. And one of the things that ChatGPT is really good at is really recognizing arbitrary delimiters. So you can just make up a delimiter and it recognizes it instantly every time. So it could be anything that you want, but quite often when I'm feeding it questions about Python, I'll wrap it in backticks like I would with a code block in Markdown. And it doesn't have any problem with that. You could just make up a delimiter as long as it doesn't appear in your text. Like ChatGPT will figure it out really quickly. But we also, those are for questions you ask ChatGPT. You also have to remember, if we look at our data here, we also are going to be processing our data with other types of data processing for analysis and for reporting and for storing things into databases and all that. So we want to make sure that for things that aren't purely just going to be fed to the ChatGPT API, that we use standards that'll work well with other tools as well. And so anyways, I have this A block, and the first item in my A block is an A snippet, right? And that is the snippet of code. So this is a really short one. It's good for example. A lot of the functions, most of the functions are a lot longer than this. This is a really short function that was in my snippets file. And then I close the A snippets block, and I open the block called A annotation here. Oops. And then it has this snippet. This is a snippet that was already provided by ChatGPT. This is a result of one of my API calls. But that part was, and part of this though is the model that I wanted to train it on for feeding my data into. So this part I kind of manually wrote in here, and then fed this ChatGPT to have it give me some code to to make it easier, so I didn't actually have to crawl the exact specifics of writing the JSON to pull the values that I wanted out of the response body. I'll let ChatGPT do that for me. So yeah, after an annotation section, I created this meta section. So we definitely, you'll see here, we really want to keep this metadata, because like little things like how many tokens, this is absolutely massive, right? Tokens are dollars and cents, right? It's how many, tokens relate to words, sort of. It's not a one-to-one mapping, but essentially, there's token values to words, and how many words that ChatGPT has to process have to relate directly to how much is this going to cost me. Really important value, and it's also you can measure of kind of like that's when you're thinking with tokens, a lot of it is cost. You could be thinking about performance engineering as well, like the system's going to process things faster, that have smaller prompts to get the same result, right? Probably the smallest or the most concise prompt that yields the result you want is going to be more performant as well. And so there's maybe some performance engineering, but I think cost is really one of the big things here. And you can, and it's great for analysis, because you can look at like, hey, I asked ChatGPT to provide an answer to the question when I formatted the question this way, and I can gather data based on that, right? And I can, again, run in same analysis again, right, with different formatting of the question, and then compare the results. And having all this data of how much tokens from the prompt side, from the completion side, total tokens, is data you really want to keep. Even if you don't think it's important, have it available to you, because you have projects that proceed, if it's not available for you while you're first start playing around with it, if things go well, it will become important to you at some point. And so I decided to use this tag called a meta. I looked at the response, so we can see down here is the response of all the stuff that the ChatGPT API feeds back to you after you make an API request. And I modeled out the stuff that I wanted to keep. There was like one thing I didn't want to keep is in this response is kind of the raw format of the actual snippet. And I'm like, I'm storing the snippet here. I don't need to keep the snippet here. There's a few other kind of irrelevant pieces of data I thought probably never going to be relevant to me. So I narrowed down just the scope to the ones that I thought were most relevant. And then yeah, I went through and I asked ChatGPT what it thought about this format, and definitely it thinks the format will feed into tokenizers and other data processing that we need to do very nicely. So now I'll get on to the API call. So here we've got our API call. And so we're going to go here. And here's the prompt. I described, what type of prompt, what we're going for here in terms of what's the best way to ask ChatGPT to give me the right type of information that'll be optimal for the outcome that I want, which I want this bot. I'm trying to make a robust bot. I want our fine-tuned AI model to be able to do code completion and help with documentation and help with questions and answers, right? A lot like ChatGPT itself can. So I really want to try to get the annotations that'll help a lot. So please provide a complete annotation for the following Python code snippet that includes information about what the code does, any relevant details, how it can be used in questions, documentation, and code, right? And one of the things you got to think about these prompts, right? Every token that we send costs us more money, and we may be sending thousands and thousands of these. And while it's, it's cheap in a sense, it's also not, you could also be processing, tens of thousands, hundreds of thousands of records and making tons and tons of API calls. And so the cost of tokens can add up. So this prompt is probably a little verbose for what I ideally like. So I want to play with it more, but it is start off based on the recommendation ChatGPT gave me. I asked it specifically, how do I, what's a good prompt for my purpose, right? And so start here, and I'm going to come back later as we get more and more in this, and we'll test, shortening this and adjusting the prompt to see how it affects the answers. But for right now, this is where we're starting. So I have the prompt is first, it's going to feed in the actual prompt, and then it's going to have a new line. And then after the prompt, it's going to put the code snippet. So we'll chop up the code snippet. And so at the end of the thing, it's going to say, hey, what is actually fed to ChatGPT will be this prompt within the colon with the new line. And it works just like you would if you typed into the ChatGPT window, right? You say, well, how do I do this, colon, and then here's what I'm asking you about the code. Right, and then we give it a new line at the end. That's really important. The default stop value, so it knows the stop is a new line. You can make different stop values if you need to, but having stop values are important. There's one thing you may not realize about ChatGPT, like when you put a period at the end of a sentence, or a question mark, or a colon, or nothing, right? Or something like part of a code file with nothing behind it, right? Those things make a really big difference to ChatGPT and how it responds. Now, you may not notice it right away because it's smart enough to where even if you give it a prompt that starts to like make it, think that you want something else, it'll like, before it actually responds back to you, it'll figure out, oh, okay, it sounded at first like what they wanted was this, but what they wanted is actually that, and it'll give you the answer. Usually gives the answer right now, but it can really actually make a lot of difference when you want very consistent answers from the API to have it really narrowed in to feed in what you want. So that does a good job for us, though. We get some good answers from that. And then we're going to make a request to the OpenAI API. Oh, and I'm going to have to clean this up because I left my token on the screen for everybody to see. So video editing for me, yay, me. But yeah, I need to clean this so where I can just have this look at a environmental variable instead, because that way I don't have to worry about having to sit here and do a bunch of video editing because I showed my token on the screen. We have our HTTP request, and we feed it which model we want. We feed it this prompt, right? We create a variable called prompt up here, and then we feed that into the prompt and what we're going to send to the API. It's good to have a max token value. My explanation of what that is here is not going to be that rich. Just get into this, look it up again. It has to do with how much text you can send. And it's not a token. There's not a one-to-one mapping between tokens and words. And so you can't say that it's exactly X words. But, 1,024 tokens make you like a page or a page and a half of data, something like that as the max. And I have to actually check. I think I'm not sure how the max relates to how large the response can be, right? Because you can, with like a lot of ChatGPT responses, you might have some of the models will support taking in a 2048 tokens, but the max tokens in some contexts would be actually like 4,096 because it reserves some part for the response. So actually, now that I think about this, I have to go and look at this a little bit more to think, is the max tokens here, are we talking total tokens? Are we talking about what I can send? Like we were looking at that data before. Here we have these things, how much the tokens I sent in my prompt and the tokens that it used to respond to me with its response, those two become the total tokens. So actually, I'm not certain now that I think about it, if the 1024 max tokens here is the total back and forth token value, or if it's just what I consider. I think it's the total back and forth token value, but that includes its analysis of my prompt and its computation of the words it responded back to me with. Now, temperature and top B are both measures related to creativity. So you want like temperature to be lower if you want it to be less creative. And so if this were purely for like code completion, it kind of depends, because if you give the model, if it's well trained enough on something, you can let it be a little bit creative even in code completion, as it may generate new code patterns that actually do work, right? But in general, like if you're just doing code completion, you want to be a little more conservative here. But even if your goal is code completion, you might use more or less temperature on which task in your overall project that you're doing. In this case, I want to generate words and descriptions about code. And I think a little bit of creativity, and that's okay, because we don't want to be inaccurate, and hopefully it won't be, right? Like from what I'm seeing so far, this doesn't lead so much to inaccuracy, is what it leads to is like, when it comes to this prompt or some keyword, what other words do we potentially associate with that? And it'll come back with a list of like, what word should I use next? And the list that it's probably come up in the background probably is going to be something that has several words that would do the trick, synonyms, right? And when humans come to this later to search, they're not always going to search for things using the same words. They're going to use a few different types of words. This person over here might use one way of describing something, somewhere else might use a different way of describing something, but it's synonymous words. And so by tweaking the temperature here, if we go too high on those values, we may start to get more into the erroneous values. But I was doing some testing in the playground, as you should do when you're doing this. Test it either both in the playground and in the regular ChatGPT web client, maybe on Bing, although the prompt on Bing, while it does do supposedly more advanced ChatGPT now, it just has too narrow of a prompt to work with data that's not very, very short. So it's hard to work with code with the Bing model right now. So anyways, so yeah, we just check the response, we save, and then we save the code, and this has some additional code in here to put it all right in the right format that I want. So let's go ahead and make some API call. Excuse me. And I need to close. I'm going to move away from this file because every second that it's showing, I'm going to have to sit here and edit on the video editor, which is going to be a pain. So let's go ahead and run this. So I'm in the test folder here. And let's just go ahead and make this a little bit bigger. There we are. We'll make it a lot bigger, make it a lot easier to see as we go through this. And I need to make sure I stay away from my tokens. Okay, so now what we're going to do is I have in my test directory here, I've got a file called codesnippets.txt, and this just has a couple small of my code snippets in the source format that I'm going to feed them in. And let's just pick a couple others so we can generate some original stuff. So let me go back to my larger file here. Let's just pick a couple random ones. So we'll start here on this one, and we'll do, let's just get like, what is that, 5 or so. We'll go ahead and copy those. I'm going to put them into this file at rest. I'm using this just to do testing on a few of these before we run those batch jobs. So now I've got 1, 2, 3, 4, I think 4 code snippets in there, and we're going to call the API and get a response back with an annotation for this, and we're also going to gather that metadata back. And so we'll run that API requests file here, and it's going to generate a file called annotated code snippets delimited.txt. So I want to make sure I don't already have one of those, and it'll probably just would make it figure it out if it didn't, but I didn't really play with the logic to know if it's that robust yet. So I actually have renamed this one to .sh, which, why did I name it .sh? Well, it's because I was actually using these response to model the new, this edition. I originally was just doing the snippet, and I added the metadata response. And so I used this, and I wanted to use AI, my Copilot code completion. And it wasn't even to do anything. It's just like, as I type these out without the AI, I have to type out or copy and paste, right? But nice thing about using that Copilot, right? Even though, what is this ID from response? Like I made that string up right there, right? But once I had the first one in, I start typing object the next line, and it fills it in, and then it knows exactly what I want. I can start typing in 1 or 2 letters, and it just makes, building a model like that. So, but the interesting thing is it doesn't work on file. It works on files based on their file name. So this isn't the shell script, but I just called it a shell script so I could get some relevant completion help on it to speed that up from Copilot. And so now we'll go ahead and so I don't have any file here called annotated snippets limited.txt. So we can see this one has a .sh on it. And so we're going to generate one like that here in a second. So the code itself will take the name of the file that you feed it and then name it. Actually, I think it's going to call it code snippets -annotated. I don't know. We'll see what it calls it when it's done. But right now it's calling the API, and we can see it's already creating the file for us. It's not done yet, but we can start to see the data that we can gather in this file. So now we could see for this first one up here, we've got this code defines a function called initialize options, which is part of the class self. The purpose of this function is set to the default values for any options that are specified in this class. This code does not do anything other than define. So it's kind of, because I asked it, the way that I asked the prompt was for it to make a very verbose annotation. I wanted that annotation to be long. So at first it was giving much more succinct. You might look at that like, well, that's pretty cool. I can figure all this out. But that's a little wordy for, a function that's like doesn't do anything to have all those words. But that's exactly what we want for really training our rich model. Have a bunch of words that are you could associate with these functions. And so really nice little annotation here. We've got our next one. It's another, let's see if we've got, let's see, 1, 2. Oh, you know what? I didn't save that before I ran it. So it ran on those original 2. Let me save those files and run it again so we get some more examples. Whoops. So I'm like, why is this giving me whatever? Oh, maybe I did. What did I do? I don't want to save that. Okay. I tried to save everything, and I apparently had made some changes into this file that I didn't want to overwrite on something. So, so we want to go ahead and actually, this time I want to make sure this file is deleted. And I want to make sure I've saved the updated input file. Because those were good responses, but those are the responses to those first 2 little ones. I want to get a couple new responses so we can see what the new responses look like. So I've got my code snippets. So I'm just going to delete that file. Because I don't know what it'll do if I already have a file named that. It may add to it. It might get confused. It might, I need like to make really robust Python code there. I'd want to test that and make sure I know how it handled it. But for the time being, I'm just trying to get stuff done real quick for this testing part. So now we've got our code snippets. Make sure this is saved. Yep, that wasn't saved. I can tell because the number here. And it went down. And I'm going to see. I'm just going to close a bunch of these files because I don't know what annotated snippets limited. That's not an important file. I'll just go ahead and save that. I'll get rid of this. Get rid of this. Leave that open. And, okay, so we've got one file left that has a change. So I'll go ahead and that's the file doesn't really matter. So everything's been saved. I can see now that I have no more unsaved in VS Code, right? Your little file explorer thing here will have a number on it, much like this does. This is saying, I have extensions that require it have that blue 2. If I have files that are unsaved, it'll have that up there. So if I would have looked at that, I would have known. Let's just run this again on that new data that we pasted in and see what interesting responses we get back. We should see. That is one of the things, like we'll tell you about the APIs, right? The more intelligent the API, the slower the response. So you can imagine here, this is taking a few seconds per API call probably. And so if you're going to batch in a lot of data here, like in that other one, you may want to do some parametric multi-processing, you're working in a way to where you can have it have multiple different processes going at the same time from multiple different source systems making the API calls. So now we're done. We've got our code snippets annotated. Let's see what it provided for us, right? So we can see here, very simple little function does something. It's hard to tell from this, like, what the heck? I imagine a human trying to be able to make a snippet from it. And I don't want to just say having a really rich annotation based on a function that doesn't do much is necessarily going to be useful. It might be counterproductive, right? You may want to have more rich, long descriptions around more bigger, chunks of code. And that's all part of the experimental process, right? And maybe and there's ways that we can balance that. Maybe we can ask the prompts to ChatGPT in a way where it'll provide longer snippets for bigger functions and shorter snippets for shorter functions. But we could also, do something like, let's say, split our data based on how long a function is a simple thing, right? And for really short functions, feed it into a batch that has a very simple prompt, or a prompt that it would result in a shorter response. And maybe then for the longer functions that you may find, hey, we definitely want a lot of words associated with those, because there's a lot more times that people will probably be thinking about that, and it's more relevant. And so you might take the longer functions and feed them in to different batch that has, and there's no one knows the answer. Like, we're getting neural networks, even people who understand the math really well, right? It can't predict what outcome they're going to have in most cases, especially very complex questions. It's just, let's make the model, let's feed it, and let's find out. And then do that a bunch of times, make tweaks, feed it in the model in different ways. And you got to be able to have do some regression models. Like, I'm going to do some, once I get enough data on these different testing, we're going to do some 5-fold linear regression models with random forests that will split our test data, our training data set, and in different ways, and then say use part of our training data to predict. We'll split our data, part of it being training data and part of it being testing data, to validate how well that the training parts of the data could predict the outcomes from the testing parts of the data. All from the same data set, we can start to do that type of stuff. Right, so we can see a nice description. I'm curious here, and we get our metadata. This one, my prompt right now is taking 103 every single time. I'm spending 103 tokens on just what I'm asking. So that's a vector for optimization, and we can see our completion tokens, how it's meant to give me a response back. And this one's going to be the same, right, between all my prompts. This one's going to vary a lot based on how long the response is. And so got another function there. Another function here. I think one of these functions a little bit longer. Yeah, so here's this function. This function does a little bit more. It's what, like 8-9 lines here, or 8, 5, 7 lines long. This code snap, this is the function definition for a class that handles an error when it is called. Right? There's not a lot that it takes in here, and this is one of the reasons why we also want to, like, I'm going to do more different types of annotation on the full code base as opposed to this. And also, you may think bringing in different cross sections that make sense. How much preprocessing you can do in a fully automated way versus manual massaging. That's a hard thing, because you need enough quantity of data where manually massaging every little piece of data is going to be hard. Even though we don't need quite as many, we still want hundreds and thousands of records. So ideally, we want to find intelligent ways to parse this data automatically. But yeah, really get a really nice, understand the signature. The function takes in 2 parameters, args and pargs, and checks if the v error is present in the edict. So that raises pop error exception. Yeah, so it's using some esoteric language, but right when you're part of what I want the bot to do is to be able to understand also too, to support developers as they're developing code. And the type of questions they might ask. You might think, hey, end users wouldn't usually ask the questions that would use language like that, but developers absolutely would. Right? And so it's really interesting stuff. So now, so that's part 1. This is just the beginning, right? I'm going to do a lot more analysis. Right? We're going to take these batch jobs next. I'm going to feed in all these batches, and we're going to end up with, somewhere between 650 and 700 code snippets that are annotated. And I'm going to move into the full source code. I'm going to do a very similar exercise to break the source code into manageable chunks to feed into the API, and do that in an automated way. It's a little tricky. And then we'll do a similar exercise using the source code to get annotations on chunks from the source code, and then we'll have things like the comments that they're present with the code that will help, and we'll also feed in a little bit larger chunks. Like, it's not going to be able to take in tons and tons of source code in a single prompt, but I want to put in try and find a moderate amount of data, because the more you're going to have, give it the ability to cross-sect across the different data and not just basing its analysis on this one tiny little part alone. And then we're going to continue on down that path and do that with the documentation. And once we do the pop source code and documentation, go ahead and push that into a fine-tuning training set and start training the model, or start testing to see how well that it's able to answer pop questions. And then we'll add in additional analysis based on some source code from some other projects that were used in POP, add an item, and hopefully pretty soon we'll get to the point where we've got popping on, and somewhere as we go along, we're going to be doing various automations. Eventually, I'm going to get to the point where everything's fully automated to be able to we'll know exactly what are the different sources, what the different options are for how we might want to tweak our parameters for different types of tests. And so we can do some tests that will come back and report on the efficacy of these different types of parameter tweaks that we may be able to do in here, and again, eventually really want to make this a living model, do things like, hey, this is stuff that's based on source code, right? We can do GitOps to analyze the differentials or when new stuff, when new releases comes out, when documentation changes, we can monitor those changes and try to feed into data sets. It's probably not, there's a lot of complexities there, with the biggest being, new stuff comes, some of that new stuff that comes might make some old stuff irrelevant. Some of the new stuff that comes might be a correction about something that was wrong in a previous code, bugs or descriptions that are in documentation that were inaccurate, things like that. And that's a tricky part, right? Like there's the whole question of how, because one thing that's clear from everything I've read about this is that invalid data can really poison the well. You really got to be careful about how much invalid. It can deal with, this is going to be doing statistical probabilities, right? So if the vast majority of data in your system is right, it's going to tend to the correct thing. But people are asking all types of questions, and depending on the question, the way it was asked, if you've got invalid data, it can really pollute the system. And for me, that's an interesting challenge I'm still wrapping my head around. Getting initial sets of data, that's interesting, but creating a model to prune data, there's lots of interesting ways to do it, but that requires the least cost and the least amount of needing to figure out ways that I would need to have bunches of humans to go in and do things. It's going to be hard for me to figure out from my experimental amateur perch here. So it'll be an interesting thing to see. We can not only have kind of a CI/CD approach to model tuning on a continuous basis, but then what will that end up being? One approach is know how I generated all of this data, and just regenerate it on a clean slate periodically, which that'll probably be how I start, and then eventually figure out, because another trick about getting bad data out, right? What if you've got some function that you remove later or that created a bug, and you ask ChatGPT to create questions and answers and descriptions and other words about that code, and later you need to come figure out what data that you have in your system that might have been somehow related to, and you've got thousands of pieces of data in your system, right? Like that's an interesting problem. And I think the answer is, once again, probably ChatGPT, to figure out how can we come up with a system that can go through and cull stale data. But yeah, it's just going to be a fun project to work on. And so I want to I'm really enjoying this. I'm going to keep on spending my weekends playing with this stuff and sharing information. Hopefully you find it interesting too. Thanks a lot for joining me today.